Hey guys, so I know that that last lesson was really tricky. And so what I'm going to do is I'm going to do another example problem for you, just like the ones that you have assigned. And I am going to do one video for each step. So there's going to be a total of 3 videos, but they're all going to be shorter. So that way if you get stuck mid-step, you can just go back to that example video, okay? So the first thing that we're going to do is I'm going to talk you through how to determine the limiting reactant if you're given the masses of the reaction. Okay, that's all we're going to do. We're just going to talk about how to figure out how to determine which one's the limiting reactant. This is going to be step A or step 1 to each one of the 2 problems that I'm having you work through today. Okay, so let's say we've got the reaction between solid white phosphorus and oxygen, and it produces solid tetraphosphorus decoxide. This compound is often called diphosphorus pentoxide because of its empirical formula, which is P2O5, but it's actually P4O10. Okay, so first of all, let's figure out what our equation is. Okay, so we've got solid white phosphorus, which is P4. Okay, so we've got P4, which is solid. And this is going to react with oxygen gas, which we know is O2. And this is going to produce the solid P4O10. Well, balanced. Phosphorus is already balanced, but we're going to need 5 oxygen molecules in order to get O10 over here. Okay, so this is our chemical equation. Now, we are known, it is told to us that we have 25 grams of phosphorus, okay? We also know that we have 50 grams of oxygen. And so we want to know what is the limiting reactant, okay? So we did step 1. Step 1 is write the balanced chemical equation. So now we want to figure out how many moles each of our reactants is, okay? So that means we need to figure out the molar mass of each of these things. So let's start with phosphorus. We have 25 grams of phosphorus. Now, we're converting from mass to moles. So we put the moles on the top, 1 mole over. Our molar mass of phosphorus is 4 times the molar mass of 1 phosphorus, which ends up giving us 123.9 grams. And so all totaled, we have 0.202 moles of P4. Now, how much oxygen do we have? We have 50 grams of oxygen times 1 mole over O2. The molar mass of that is 32, rounded. So 50 grams divided by 32 gives us 1.56 moles of O2. So now we have to figure out which one of these ratios is closest to the actual thing. So first of all, let's calculate our ratio of actual available element, okay? So our ratio of oxygen to phosphorus is 1.56 to 0.202. Now, again, this is a terrible ratio. Ratios need 1s in them. So we're going to divide both of the numbers by the smaller number. So divided by 0.202 divided by 0.202. 0.202 divided by 0.202 equals 1. 1.56 divided by 0.202 gives you 7.72. And this is O2, and this is P4. Now, let's go back up to our chemical equation and figure out what that ratio is supposed to be. That ratio is supposed to be 5 moles of O2 for every 1 mole of P4, okay? This means that we have extra O2. We have 7.7 moles of it, ratio-wise, but we only need 5, okay? So this means that P4 is limiting, which means that oxygen is excess, okay? So that is how you determine which one is a limiting reactant. Watch the next video to go from determining which is the limiting reactant to figure out how much product is going to be produced, okay?